Okay, so we're going to pick up example 3 here, section 1.5. This is, it says use a graph, and this should say use a graph or tables to solve that equation. So in this equation, what you notice, you've got an x squared equation, so that's going to be u-shaped. And then you've got a mx plus b, so you've got a linear. So we're going to have a u-shaped graph and a linear graph when we go to graph this. And you should know that before you get into the problem. You know by just looking at the equations what type of things we're going to get. Now we're going to use our calculator for this. You can also use some web-based apps, which I'll give you guys a little info on that later on. But for this, we'll get right into our calculator. So it's going to start it the same way as we started the examples yesterday. So we go to our y equals. If you got stuff in there, clear them out. And you're going to put one equation into y1 and the other side of the equation into y2. So we'll go ahead and just type it in. So we go x squared minus 4x plus 1. And then you got your x minus 2. And I would follow along as you do this to kind of see if you can get the same thing to happen on your graph or two. All right, so we get those in there, and then we should be able to press graph, and it should graph this for us. So we press graph, and we're looking pretty good there. So we get exactly what we expected. We get a U-shaped graph, we get a linear function, and what we want to keep in mind here is solutions are where the graphs intersect. So looking at this, you should see they intersect twice. So we're going to expect 2 solutions from this, and we need to know where those are at. Now what we're going to run into the problem here is this value isn't at a whole number. It looks like it might be at 1, but maybe it's at 0.8, maybe it's at 1.3. We don't really know exactly what x value that falls at. So I'm going to show you some things just to kind of make you understand the big picture of this. Aside from the graph, this also makes tables. So if you press second graph, see how it says table right there? You can press second graph, and it'll jump to a table. And so if you remember, we said that we thought that these looked like they were the same right around 1. Well, what you see is at 1, they're very close to the same thing, but they're not the same thing. In fact, you can actually see that originally this graph is higher than that one, but then after 1, now that graph's higher. So basically, in other words, somewhere between 0 and 1, those graphs had to have crossed. Now, do we know the exact number from the table? No, we don't. Maybe it's 0.8, maybe it's 0.9, maybe it's 0.3. We don't really know. But somewhere between 0 and 1, they do cross. So the table's cool. The table's really useful for plotting points and making graphs, like we talked a little bit about yesterday. But again, you got your table there. But let's jump back to our graph. So I want to know the coordinate of this. Without having to do any math or any manipulation of the equation, there's a function in here that just shows it to you. So it's in this, what's called the calc menu. So what you're going to do is you're actually going to press second trace to get to your calc menu. And this calc menu, we're going to use this a ton throughout the year. But right now, we want to know where these 2 lines intersect. So we're going to pick the obvious choice of intersect. So you can either scroll down and press enter, or if you want to do it more efficiently, just press 5, and it'll pick that option for you. So once you pick intersect, now it'll ask you a couple questions. These questions aren't actually very important because we're only going to graph 2 lines at once. It's going to say first curve, second curve, and guess. All you really need to do is, since there's 2 different intersections, just put your cursor, and you move your cursor with left or right. Put your cursor just near wherever that first intersection is. And then all you have to do is you have to press enter 3 times. Because these questions it asks aren't going to impact what we're doing. So we're just going to go enter, enter, enter. It thinks for a second. And then it's going to say your intersection is at this value. And so it gives us, to 8 decimal places, that x coordinate. And remember, we don't care about the y, because this problem's only about x's. When we look at the equation, we want the x value. So we can write this down. And a lot of times they say go to the nearest, I think most of them say thousandth, but sometimes they say tenth. So read your problem to know what you got to round to. But we'd say this one is at 0.697. So that's the x value for the first intersection point. Now to get the second one, we just repeat that same step. So we just do, just to kind of see it from the top again, second trace, brings up your calc menu, pick option 5 for intersect, and then since we want this other one, move our cursor over here. So again, left and right will move your cursor. You get it over near the intersection. And then it's just enter 3 times. Enter, enter, enter. And then it'll give us this x coordinate. So same exact concept. We can just write that one down. So nearest thousandth would be 303. And there we go. So we were able to solve this equation without having to actually do any algebraic work. We graphed it. We used the the graphing to find the intersection points. Really nice when you get kind of ugly answers like this. I'll be honest, this problem without a graphing calculator is very difficult to solve. Sorry, very difficult is maybe the wrong word. It takes a very long time to solve. So anyway, that's the kind of the idea there. So what I want you to check out here is you'll notice the very next problem is the same kind of thing. Ignore this altogether. This doesn't need to be here. This is for the different problem. But it gives you another equation. I want you to try put this in your y equals, put this in your y2, see if you can come up with the two solutions. So try it on your own, and if you got questions, let me know. Yep. All right, so I already put the equations in here. So again, I just put my left side in, I put my right side in. Some of the common mistakes I saw that I was pointing out for everybody is the way these calculators are programmed is, to them, negative and minus are different things, even though technically negative and minus, like to us, are not different things. But when you're putting a negative in front of a number, you have to use the negative key. And anytime you're doing subtraction, like here or here, you have to use the subtraction key. It's just the way the calculator is programmed. So if you get errors, that's a lot of times one of the most common errors that pop up. So just to point that out. All right, so I graph these, and I should get an absolute value, and I should get a U-shaped graph. So if there's my U-shape, there's my absolute value, looking good. Another thing that comes up is as you do problems, you're going to need to zoom in and zoom out sometimes. So this zoom button has a lot of options in it, like zoom in, zoom out, zoom standard. Those are kind of the main ones we use. But you'll probably at some point today have to use zoom out. So if you pick zoom out and you press enter, it'll zoom out. And it makes your graph look different, obviously, because now it's like you're zoomed out. You're further away from it. So if you ever look at yours and yours doesn't like match something I'm showing, that's probably the main reason. I almost always start in zoom standard. So zoom and then option 6. So I just press zoom 6. That way I know I'm looking at my normal negative 10 to 10 graph. And then I kind of go from there. If I need to adjust it, I'll adjust it from there. So sometimes you will zoom in, sometimes you will zoom out. But most time, stay at standard and then adjust from there if you need to. So that's kind of just a lot of little base things to keep in mind. But now to answer our question, we want these intersection points. So we go just what we just learned. Second trace, pick option 5 for the intersection. And then if you ever lose your cursor, this tells you where it's at. If I'm at negative, like if I'm at a negative x value, I know I need to go right until I can see it. There we go. There he is. So now I can bring him to that first intersection. And then again, it's just enter 3 times. 1, 2, 3. And it tells me my value. So this problem, I think, says round it to the nearest 10th. So I'm going to go ahead and write those down, nearest 10th. So this one will just be 2.7. And then repeat your intersection steps to find the other one. So go same thing, second trace, intersect, and over here, 1, 2, 3. And there we go. So 5.3 for that one. Again, it's always the x values that we care about. The y just helps us graph it. Because technically, this problem has no y to it. So you're just solving for an x value. Again, as you practice this and you get better at it, you're going to find it's a really nice concept to understand. Okay?